We're going to talk about an associated program here called the total trip theorem. This is what Papert described as a turtle's trip all the way around a polygon. Its exterior angles come up to 360 degrees. Now we're repurposing our old program, and this is the program we're going to use, and it looks very similar to the program that we've already discussed. This time we have two variables, polygon sides and polygon's side length. Now, the repeat block in these last two commands are exactly the same as our other ones, except instead of being called ellipse, they're called polygon. So our polygon sides is our polygon 4 by polygon side length. So this one's going to be 50 units long, and it's going to turn by 360 divided by polygon side. In this case, we're making a triangle, so it's 3. So it's 360 divided by 3. So our exterior angle, or our turn angle, is going to be 120 degrees, and hopefully you know now that that's going to make a equilateral triangle. Now these top four commands are just a tracking device, so that I'm turning the color of the pen blue. I'm going to go forward 50 plus the polygon side length, which in this case is 50, so it's going to go forward by 100. Then it's going to go forward by a negative 50 minus the polygon side length, which means I'm basically going to go back 100, so I got back where I started. Then I'm going to change the pen color to red, then I'm going to draw my polygon. Now there's two ways to fire the script. I can click the ellipse like we've done in the past, or I've also made a draw button. And that's easy to make by clicking here and say I want a button to fire the script. I'm not going to do that though. I'm just going to, because I already have my button here. So if I click this, it's going to draw my 50-sided polygon with these arrows or these lines extending from it. And this is good because now it's really easy to see that I turn 120, 120, 120 degrees to get me back where I came from. If I change this 50 to 25, it's a little bit easier to see these turn angles, summing up to 360. If I change it to 10, it's a little easier to see. If I change it to 1, it's really easy to see. But what's even better is if I change this to 0, I can clearly see now that if I start here, I take 1, 2, 3 steps to get back where I started. Total turtle trip is 360 degrees, which means each of these steps is 120. 120, 240, 360. Now this is the same as this, but as I show this progression, I can really clearly see that yes, in fact, each of these is 360 degrees. To drive the point home, I can choose any polygon I want here. By changing this to 5, I should be drawing a pentagon with side lengths of 50. There's my pentagon with side lengths of 50. I can change it to 25. My same polygon, a little bit smaller. And it becomes very evident that now I have my polygon 1, 2, 3, 4, 5 steps at 360 degrees each, tells me that each of these steps is 72 degrees. I can see the same thing here, but as the polygon gets progressively smaller, it's easier to see. And one more time, just for good measure, let's do the square because it is easier to see. There it is at 50, 25, 10, 1, and 0. And once again, it's easy to see the square. So now it's really easy to say, oh look, yes, the interior and exterior angle are both 90. So when we did it the first time, we really got lucky. But as we reduce the size of the side length, it's really easy to see that 1, 2, 3, 4 steps 360 in 4 steps is 90 degrees each. 90, 180, 270, 360. Okay, thank you. Don't forget to save.